Hi. Welcome to our third video to learn how to build program logic. In this video we are going to see how to build logic to check whether a given number is a prime number or not. We are going to see here. First, what is a prime number? Next, how to build logic to implement the program for identifying a prime number. Next, some examples of finding a prime number. Next, steps for identifying a prime number. Next, the actual prime number identifying program. And finally, dry run for number 7. So let's begin. And remember to always focus on how the program logic is getting built. So what is a prime number? A number is a prime number only if it is completely divisible by 1 or by itself. No other natural number can divide a prime number completely. So how does one build the logic for the program? Simply follow the definition of the prime number. But can we improve on the logic? Let us look at some examples of a prime number. The first example is 7. Let's divide the number 7 starting from 1. 1 divides 7 completely. Next, 2 does not divide 7 completely. Next, 3 does not divide 7 completely. Next, 4 does not divide 7 completely. Next, 5 does not divide 7 completely. Next, 6 does not divide 7 completely. And 7 divides 7 completely. And so 7 is a prime number. Let's take one more example, 25. 1 divides 25 completely. Next, 2 does not divide 25 completely. Next, 3 does not divide 25 completely. Next, 4 does not divide 25 completely. 5 divides 25 completely. And so 25 is not a prime number. So let us now think how we can improve the logic. Instead of using terminating at divisor equal to the number, can we use condition as till divisor less than half of the number? Is it correct? Let us take number is 7. And initial divisor value as 2. So no divisor less than 2 is allowed to divide 7. We will identify as statement 1. Now 4 is greater than half of 7. So for 7 by 4, quotient will be less than 2. Also, quotient for completely divisibility operation also can completely divide the number itself. As 2 completely divides 8 to give quotient 4, 4 also completely divides 8 to give quotient 2. If any quotient less than 2 for completely divisibility of 7 is acceptable, then it should be acceptable as divisor that completely divides 7. But that contradicts our statement 1. So value of divisor cannot be greater than half of the number. So we can stop dividing at less than the half of 7. The advantage is that it reduces number of cycles. So what are the basic steps of the program logic? First, divide the number by divisor starting from 2. Next, if divisor divides completely, then the number is not prime and then stop. Else increase the divisor by 1 and repeat steps 1 and 2 or 3 till divisor is less than half of the number. So now we will start writing the actual program for identifying a prime number. We start with the include and main statements. Main bracket opened and bracket closed. A programmer always puts right curly bracket as in when she puts a left curly bracket. This way one can avoid lot many errors. We then declare a variable num to store a number value. We then declare an prime function with one integer parameter. Then a printf function to prompt the user to enter a number. Then a scanf function to accept the value for the same. We then make a call to the prime function with argument as num. And then with a getCh function and return 0 statement we end our main function. Now we will see the code for prime function. The function has one parameter num of type int. We declare a variable dvsr initialized to 2 to divide each value of num. We then have a if condition which where the num modulus dvsr is equal to 0. If yes, we stop the loop execution as per step 2. Else we increase the value of dvsr by 1. The statements from the if condition till incrementation of dvsr are in a loop which will run till dvsr value is less than half of num. Then we have print statements which will print the number is prime if DVSR value is greater than half of num. Else it will print that the number is not prime. Finally, with return 0 statement we end the function. Now, let us do a dry run with number 7. We will assume that main function was executed and the prime function was called with the value 7 for num. Then DVSR is initialized to. Then while condition is checked which is true. Here, the if condition is checked which is not true. The value of DVSR is then increased by 1 and becomes 3. And the loop cycle ends. The while condition is again checked which is true. The if condition is checked again which is not true. The value of DVSR is then increased by 1 and becomes 4. And the loop cycle ends. The while condition is again checked and it false this time as DVSR is greater than half of 7. The control goes to the if condition after the while loop which is true. And so 7 is printed as a prime number. The return 0 statement is executed and the control is transferred back to the main function. After executing getCH function and return 0 statement of main, the program execution ends. If you found this video useful then please like it. Also do subscribe to the channel by clicking on the subscribe button. Also share this video and playlist with your friends. Thank you for watching.